We've seen that differential equations can have more than one solution. So whenever we talk about solutions for a differential equation, we need to be careful about whether we're looking for just a solution or whether we're looking for all solutions. Typically, when you are looking at a differential equation, you want to know all solutions because you won't know ahead of time which is the solution that you want. So here's an example. This differential equation, y prime equals 2y, it has as one solution e to the 2x. So you can check that this really is a solution. The derivative of this is 2e to the 2x. And then if you plug that into the differential equation, you get 2e to the 2x. Is that really equal to 2 times y? Y is e to the 2x. Yes, these are the same. So this really is a solution. When you have a single solution to a differential equation, often it gets called a particular solution, just to emphasize the fact that this is not all solutions to the differential equation. It's just one of many solutions. So when we talk about all solutions, if we can express all solutions to a differential equation to emphasize the fact that we're really writing down all of the solutions, we call an expression of all solutions the general solution to a differential equation. So the goal, if we're ever able to solve differential equations, the goal is always to come up with a general solution, because the general solution is all solutions, whereas a particular solution is just one solution. If you can write down all solutions, that is a general solution, then you can do some extra work to find the particular solution that you want, if there's only one that you want for some reason. So for this particular example, let's see if we can come up with a general solution. So if we read this differential equation out loud to ourselves, we're looking for a function whose derivative is twice what it started as. So it's true that e to the 2x is such a function, but are there any other functions? Well, it turns out if you multiply e to the 2x by any number, that also is a solution, which again we can check. So let's take a derivative. We get 2 times capital A e to the 2x. And then plug this into the original differential equation. We get a at 2 times a e to the 2x. Is that equal to the right-hand side of the equation, 2 times y, but y is a e to the 2x? Yes, those are the same. So this is this formula, a times e to the 2x, represents even more solutions than just e to the 2x, right? Because we can multiply it by any real number out front. What we don't know at this point is if this formula actually gives us all solutions. So it's possible that there could be other solutions that don't match this formula and that we've missed. In fact, though, for this particular differential equation, this is all solutions to the differential equation. I won't really justify that. You're going to have to take my word for it. But this is all solutions for this differential equation, and so a times e to the 2x, this is a general solution to this particular differential equation, y prime equals 2y. So always when we're solving a differential equation, we'd like to find all of the solutions, so we're really looking for a general solution. So as an example, let's see which family of functions here is a general solution to the differential equation y prime minus 2y equals 4. Well, you know, as with any other possible solution to a differential equation, we can check which one is really a family of solutions by plugging them into the differential equation and just seeing which one works, if either of them. So to do that, let's try this first one. So first we need to take a derivative. And when we take a derivative, remember the independent variable here is x. C is some constant that for any single member of this family of functions, C is a constant. if you change the value of c, what you're changing is you're changing which solution you're talking about. So I guess the math jargon way to say that is c parameterizes the family of solutions. So c isn't a variable, c determines which function you're talking about. Okay, so for any single function in this family of functions, c is a constant. So when we take a derivative with respect to x, this first term just gives us 0. All right, plus 2e to the 2x. Right, now we can plug both of these into the original differential equation to see what happens. So y prime, that's 2e to the x, minus 2 times y, and y is minus 2c plus e to the 2x. And we need to see, is this always equal to 4? Now, when this equals, this is supposed to be equality of functions. So we're not concerned, we don't really care if the function on the left-hand side is equal to 4 for a particular x value. What we want to know is, are both sides of this equation equal for every value of x? So this equal is as functions, i.e. for all x. Okay, so with that in mind, let's simplify the left-hand side. So here we have a 2e to the x minus, so I guess plus 4c, and then minus 2e to the 2x. So these things cancel, and we get 4c equals 4. So are these always the same? Well, they aren't always the same. It's true that these are equal only if c is 1, but that means that a lot of the functions in this family of functions are not solutions. In fact, this entire family of functions only has one solution. So this is not a general solution to the differential equation, because most of these functions aren't solutions at all. Okay, let's try this one. So again, we need to take a derivative. We get c times e to the 2x. Remember, c acts like a constant, so it just, constant multiple rule says it survives the differentiation. And then let's plug this into the differential equation. So we get y prime, which is c e to the 2x, minus 2 times y, and y is minus 2 plus capital C e to the 2x. And we want to check, is this equal to 4? So we get c e to the 2x plus 4 minus 2c e to the 2x. Yes, that is 4. Right? And notice that it's 4 for all values of x and all values of c. So this family of solutions, or this family of functions, really are all solutions. And in fact, again, we don't have any way to really know this, but in fact, these solutions are all solutions to the differential equation. And so this formula is, this family of solutions is the general solution to the differential equation. What we'll find is, to get a general solution, there's always going to be some constant that can be any value like this, some new variable that parameterizes the families in the general solution, because differential equations pretty much always have infinitely many solutions, and so you'll need to have some kind of parameter to parameterize the family of functions, in addition to the independent variable.